Everyone, my name is Krutik Patil, and today I am excited to present my internship project titled Washing Machine Prototype, which I completed during my online internship program at Emertxe. This project gave me a great opportunity to apply the embedded system concepts I learned in the program and build a simulated version of a semi-automatic washing machine using the microcontroller and embedded C. In the next few minutes, I will walk you through the skills I learned, the objectives of the project, the tools and components I used, how the system works, and finally, what I took away from this experience. Throughout the internship, I gained hands-on experience with a wide range of technical topics that are crucial in embedded systems development. First, I learned the fundamentals of C programming and how it's adapted for embedded applications. Unlike regular C programs, embedded C interacts directly with memory, registers, and hardware peripherals. Then I explored embedded systems, understanding how hardware and software come together for a specific task. We covered types of embedded systems, real-time constraints, and how devices make autonomous decisions. Next, I worked with microcontrollers, focusing on PIC16F877A. I learned its pin configuration, how ports are used to connect peripherals, and how internal modules like timers and interrupts work. One of the most useful practical skills was switch interfacing, that is the digital keypad interfacing. I connected switches to the microcontroller for user input and using them to control everything from washing mode selection to starting the machine. I also learned about the level and edge triggering, which is used to detect how and when a button is pressed, whether it's pressed once, held down, or released. Then came interrupts, which allow the system to respond immediately to important events like time overflows or user inputs without constantly checking for changes. I also use timers to create delays for each stage in the washing process. I calculated preload values to control how long each operation lasts. A big part of the user interface was CLCD, that is the character LCD display. I used it to show the selected mode, water level, and current washing status. I worked with a buzzer which acts as a notification alert that when the cycle is complete and a fan that simulates the washing motor during operation. Finally, I use the development tools like MPLAB to write and debug code, the XC8 compiler to compile embedded C, and PicsimLab to simulate everything virtually, since the internship was conducted fully online. These skills gave me both theoretical clarity and practical confidence to build real-time embedded system projects. The main goal of this project was to simulate a semi-automatic washing machine using the embedded systems. The machine should support multiple wash programs, allow the user to select water levels, and control the entire process through switch inputs. I wanted to display live updates using the LCD, manage stage timings user using timers, and simulate outputs like the motor and buzzer. Ultimately, the project helped me apply multiple embedded concepts into an integrated working system. To develop this project, I used the combination of tools and peripherals. The tools used were MPLAB for writing and debugging embedded code, XC8 Compiler to convert code into machine level instructions, PicsimLab, a simulation environment to test my project without hardware. Peripherals for simulation were PIC16F877A Microcontroller, that is the main controller of the system, digital keypad for user input and mode selection, CLCD to show washing status and options, buzzer that is the sound alert for the cycle completion, fan for washing and spinning function, switches for power and manual control inputs. The system was designed with several functional goals in mind. The user controls the system through switches to select the desired washing mode. After that, they choose a suitable water level, for example, auto, low, medium, high, or max. A key feature I added is that if the door is open during any part of the cycle, the machine pauses automatically. This simulates a real world safety behavior. The, C, the CLCD constantly shows the selected mode, water level, and process status. Timer interrupts are used to manage delays for wash, rinse, and spin stages. A fan is turned on during these stages to simulate the working motor. Finally, a buzzer gives an alert to indicate that the wash cycle is complete. These requirements help in designing a complete embedded solution that feels like a real washing machine. Let me walk you through the working of this system step by step. First, the system is powered on and waits for the user input. The user uses switches to select the washing modes like daily, heavy, whites, woolens, etc. Once the mode is selected, the system asks for the water level input, which can be auto, low, medium, high, or max. After both selections, the system gets ready to begin the washing cycle. A key feature here is the door check. If the door is open during any operation, the machine will pause immediately. It will only resume when the door is closed again. The washing process then begins following the sequence like wash, rinse, then spin. Each stage is timed using a timer interrupt and the fan turns on during active stages to simulate motor activity. Once the full cycle is completed, a buzzer goes on to let the user know the machine is done. This working model demonstrates real-time embedded control, safety features, and user interaction, all within a simulated environment. To conclude, this internship helped me understand how embedded systems are built and controlled in real time. I got to apply C programming practically, configure microcontroller registers, work with input output devices, and simulate an actual application. It improved my ability to think logically, debug efficiently, and design user friendly interfaces using LCDs and switches. Using real tools like MPLAB, XC8, and PicsimLab made the experience much more hands on, even in a virtual setting. This project gave me the confidence to handle complete embedded projects on my own. I would sincerely thank Emertxe for providing such a well structured online internship. The mentors were very supportive and the learning resources were clear and well paced. I really appreciated how the program focused on not just theory part but also building and simulating real projects. Thanks to their guidance, I was able to complete this project confidently and learn deeply. Thank you all for listening to my presentation. I hope you found it interesting and informative. That concludes my presentation part of the internship program. Now I would like to quickly give you a live demonstration of the washing machine prototype using PicsimLab. So let me just switch over to PicsimLab and I will walk you through the working system step by step. So this is how the PicsimLab looks like. Here you can see the board selected is PIC Genius and the microcontroller is PIC16F877A. This is so it says that press key 5 to power on the washing machine. Let's do that. This switch is the switch 5. Powering on washing machine. So now we have to select the different modes. I have added 12 different modes. You can see you have to scroll this. We can scroll this by switching the by pressing the switch 5, switch 4 like this. Delicate whites, strain wash, cottons. You can see I am scrolling with switch 4. So for example, let's consider we have to select the mode as daily. So for selecting the mode, I have to long press the switch 4. The daily mode is selected. Now I want to select the water level. Same way for selecting the water, here I can scroll it with switch 4 like this. Low, medium, high, max. So let's consider, for example, I have to consider the water level as low. Again, I have to long press the switch 4 to select that mode, to select that water level. Now it says press, press switch 5 to start. So let's start our machine. This one is the switch 5. You can see this program in time. The machine has been started. It shows the function. The function going on is the wash function. The fan is rotating. If I press the switch 6, it pauses. Let me show you how. This is the switch 6. You can see the timer is stopped. It has been paused. The motor has been paused. So let me resume it by clicking the switch 5. Yes. If by someone opens the door, it will give an alert like this. This is for the safety purpose. You can see as the time is decreasing, the function has changed to pins. Now it is spin. Program completed. Please remove the scan and the buzzer notification that you have heard now. Again, it goes on the washing program to select the different option. So this is how I have done with my project. That is the washing machine prototype with Emertxe. Thank you.